All right, this is lesson 4.5, and this is how to graph the tangent function. So going off of what we were doing in 4.4 when we graphed sine and cosine, we're going to do today tangent, cotangent, secant, and cosecant. So tangent is a lot different than sine and cosine. The domain is not all real numbers because if you remember, tangent of pi halves or tangent of 90 doesn't exist, okay? These are going to be vertical asymptotes. The range is all real numbers. So these graphs are going to have arrows. They're going to have vertical asymptotes, and then each branch is going to have arrows on both ends. There are infinitely many x-intercepts that happen: 0, pi, 2 pi, 3 pi, 4 pi, multiples of pi. We only have one y-intercept at 0. We have an infinite number of infinite discontinuities at pi halves, 3 pi halves, 5 pi halves, 7 pi halves, multiples of pi halves plus or minus pi. These are your asymptotes. The points of discontinuity are also your asymptotes. The parent function is an odd function, okay, so it's symmetrical about the origin. There are no mins and maxes. End behavior. There is no end behavior because this graph goes to infinity and negative infinity, okay, within each set of asymptotes. So it's kind of an interesting graph. It still is considered to oscillate between negative infinity and infinity. Now this is where it also differs. Sine and cosine have a period of 2 pi. Tangent only has a period of pi. Here's your A, B, C, and D, and then we'll go through what they all do. Same as with sine, cosine, sine and cosine. So here's what you do to graph tangent. You are going to go through and find all of your asymptotes, x-intercepts, and then the points between the asymptotes and x-intercepts. These do not have an inflection point like a cubic. These actually do go kind of at a 45-degree angle for the parent function. They can twist a little bit depending upon if there's a vertical stretch or a vertical shrink, but otherwise these do not flatten out like y equals x cubed. So A has the same effects. If it's bigger than 1, we have a vertical stretch. If it's between 0 and 1, we have a vertical shrink. And then if it's negative, the graph gets reflected about the x-axis. So here, similar to sine and cosine, except for different, is my period for tangent is pi. So I take pi divided by b. That'll tell me my period. So again, if b is bigger than 1, we have a horizontal shrink. Or if it's between 0 and 1, we have a horizontal stretch. This is how you find your asymptotes. So when you have B and C. Again, C is going to give you your horizontal shift. So to find two consecutive vertical asymptotes for any tangent function of this form, your two initial asymptotes, you take bx plus c and you set it equal to a negative pi halves, and then you take bx plus c and you set it equal to a positive pi halves. This will give you 2 to start with, and then you can determine your period, and then they will repeat at that interval. And then D is going to be your vertical shift.